Hello everyone and welcome back to the channel. Today we will be solving Epic Institute round question C, Basil's garden. You have n flowers in a row. Ith of them initially has a height of h of I meters. Every second wind will blow from left to right, causing height of some flowers to decrease. For each second, whichever flower is strictly greater than the flower to its right, its value will decrease by 1. You need to find how many seconds will pass before each of the flowers become 0. Each of the flowers height becomes 0. Okay, I'll explain you this question using the first test case. 1 1 2. So after 1 second this will turn into 1 1 1. The last flower always decreases no matter what. After 2 seconds, it turns into 110. After 3 seconds, it turns into 100. Since 1 is greater than 0, it decreases by 1. After 4 seconds, all of the 3 become 0. So for each test, you need to print how many seconds does it take for all of the numbers to turn into zeros. Okay, so let's take a test case 1 triple 2 double 3. Now for each flower, if you calculate how much time does each flower take to turn into 0, that means the max of all of them will be the answer, because each second the operation is performed on each of the flowers. So if we get some random values, and these are the values, how these values state how much time does the ith flower take to turn into 0. That means the max of all of this will be the answer, right? So let's find this. Now since I need my current element to be strictly greater than its rightmost element, I will start iterating from the back. Okay, this flower takes 3 seconds to turn into 0. Okay, this flower will take 4 seconds. Why is that? If we keep two flowers 3 and 3, brute force it, it becomes 3 and 2, 2 and 1, 1 and 0, 0 and 0. So it requires one operation for it to become strictly greater than its right element. So this flower needs to wait 1 second before decreasing, and it takes 3 seconds to turn into 0. Hence, the answer is 3 plus 1, where 1 is the wait time and 3 is the time required for it to turn into 0. Okay, now let's take in 2. First, now see, its strictly rightmost element is waiting 1 second. So, and 2 is less than 3. It is not yet greater than its right element. So 2 also needs to wait until 3 becomes strictly less than 2. How much time does 3 take to become strictly less than 2? It is 3 minus 2 plus 1, which is 2. So it takes 2 seconds for 3 to become strictly lesser than 2. And 3 is waiting for 1 second. Hence, 2 will have to wait a total of 3 seconds. And it takes 2 seconds for it to turn into 0. So a total of 5 seconds is required for 2 to turn into 0. Now this 2, its rightmost element is waiting for 3 seconds. So it will also have to wait for 3 seconds. Then 2 will require 1 second to become strictly less than its leftmost neighbor. Hence, it will need to wait total of 4 seconds, and it requires 2 to turn into 0. Hence, total operation 6. Similarly, we get the array of all the elements and we simply print the maximum of it. If you have something greater over here, like 10, 10 does not need to wait. It is already strictly greater than 2. Hence, the answer for this is directly 10. I don't need to add the waiting time. Okay. Now, to this logic, there is one corner case remaining, which we need to handle. Let's take a case like 3, 2, 2. Okay. This is the total time and this is the wait time. Okay. 2, 2 requires 0 wait time and 2 seconds for it to drop. Now 2, it will have to wait for 1 second for this element to become strictly less. It waits 1 second and requires 2 seconds to turn into 0. Hence total of 3 seconds. Now I would directly write that this value takes 3 seconds. It is already strictly greater than 2. Okay, it is already strictly greater than 2. Hence it does not need to wait and directly the answer turns out to be 3. But no, this is not true. If your array is 3 2 2, let's brute force it. It turns into 2 2 1, 2 1 0, 2 double, sorry, 1 double 0, triple 0. So it took a total of 4 operations for it to turn into 0, not 3. Now, after examining multiple test cases, I found out that we need to check one last value, that is this line. The answer for the current index may be answer of I plus 1 plus 1. Means if I say some ith index is taking 5 seconds to drop down to 0, that means my I minus 1 index may take 6 seconds. Means it at least will take 6 seconds. Always. And this is why. Let's pick up a test case like 6 and 5. Just like the previous one. This turns 5 4. Then 3 2. No wait. This has 6 only, right? I'll take something like triple 6. No wait. I'll take triple 6. This takes 6 seconds. This will have 1 second of wait. I'll take this as 7. No, 7. Okay. This has 1 second of wait plus 6 seconds to drop. Hence 7 seconds. Now this is strictly greater than 6. Hence it should directly drop to 7. But no. I will take 7 plus 1 and 8. Why? Now see, if you have two values like this, 3 and 2, which means if 3 has to decrease, 2 also needs to decrease. I'll explain this in more brief way. Why is this true? If you have 3 and 2, then this turns into 2 and 2. Now this 2 cannot decrease any further until this 2 turns into 1. And hence it needs to wait an extra second for this to turn into 1, and then this can turn into 0. Okay, so I was very sketchy about how much should I add to my answer, considering few test cases like 7 triple 6, then I checked 5 4 3, and I checked multiple cases. All of them worked with this single line, that for a current answer, the answer for it is answer of I plus 1 plus 1. Okay, so this is the implementation. First of all, this answer array contains the time required for that element to drop. Time stores the waiting time. Okay, first of all, the last element has 0 waiting time and takes exactly a by time to drop. Okay, now if a of I is less than a of I plus 1. It needs to wait for a of I plus 1 to decrease. So the waiting time will be the time required to decrease plus the time required for the right moves to decrease. Then the answer is supposed to be a of I plus the waiting time. And the corner case which I mentioned just now, answer of y is equals to max, answer of y, answer of I plus 1. This case I got solely by checking more and more test cases. Okay, and then the answer is just printing max of all of the possible answers. Okay, so thank you guys for watching. Make sure to like and subscribe to the video to never miss another tutorial.